My plan was to put this up yesterday, but as they say, things happen. So we're going to do it now. Now, fractions is how many parts do you have out of how many it was cut up into, and it's equal pieces. So I did this problem a long time ago. A third would be like this. A fourth would be like this. And this says I have one of the three pieces. This says I have one of the four. So, example, let's say I have two pies, a coconut cream and an apple. And I have one slice of the three-slice coconut cream pie, and one slice of the four-slice apple pie. And the question is, do I have enough for breakfast? Now, just looking at it, I can about tell you I don't. But I need to recut the pie so I have the same slice pies. So I find what's called the LCD. Recut the pie. So, the LCD is the highest power each unique item occurs. Let me say this again. It's the highest power each unique item occurs in each denominator. So this is 3 to the first. This is 2 squared. So I have 1 3. I have no 3. So I need a 3. Highest power occurs is 1. I have no 2. I have 2 2s. So the highest power 2 occurs is 2. Well, that would be 12. So I'm going to recut the pie into 12 slices. So 3 times 4 is 12. I got to multiply the top by 4. 4 times 3 is 12. So I'll multiply the top by 3 and the bottom by 3. So that would be 7 twelfths. So this one, I have a 2 and a 3. I have a 3 squared. So I need the 2 to the first, 3 squared. That would be 18. So recut the pie. So 3 times 6 is 18. Multiply top by 3. 3x plus 3. It's getting dark in here. 9 times 2 is 18. So multiply top by 2. Then combine 3x plus 2x is 5x. 3 plus minus 4, can't say it. 3 minus 4 is minus 1 over 18. You keep the denominators the same. That's how many slices the pie was cut up into. Pie. So this is 5, this is 10, so the LCD would be 10. 2 times 5. So this I don't change. This one I got to multiply top and the bottom by 2. Now here's where you got to be careful. The bottom is 10, but it's x minus 2x would be minus x. And minus 3 minus a minus 4 would be plus 4. So that would be plus 1. Now this is the one most people mess up. X and x plus 1 are unique from each other, so I need both. I need both. You are so lucky I came close to singing. So what do you multiply 2 by? What's missing from the x to get the x plus 1? So that'd be 2x plus 2. What are you missing from the x plus 1 to get x plus 1? And that'd be x. So it's 5x plus 2 over x plus 1. Here. So what's the highest power each unique item occurs? I have a 2, don't have a 2, so I need a 2. Here I have an x to the first, I have an x squared, so I need x squared. So this one's missing a 2, so multiply top by 2. This one's missing an x, so 3 times x, so it'd be 3x plus 10 over 2x squared. This one factor would be x plus 2, x minus 2. This is just x plus 2. So notice I have an x plus 2 in each, so I need x plus 2. Highest power is 1. And this I have an x minus 2. Don't have an x minus 2. Highest power that occurs is once. So I'd have x plus 2, x minus 2, x plus 2, x minus 2. So I already have it. Here I'm missing 1 x minus 2 here. So I'm going to multiply at the top by it. So I can have it in the denominator. Then combine it, it would be 3x over x plus 2, x minus 2. Now some books say you should FOIL the bottom out. Some books say no, leave it factored. So let's try one more and then we'll be done. So let's say we have x plus 3 with an x on top plus 4 with an x squared plus 6x plus 9. So I need to factor this. It'd be x plus 3, x plus 3. So it'd be x plus 3 squared. So I have 1x plus 3, I have 2x plus 3s. So I need 2, the highest power it occurs. So I already have 2, so just bring down to 4. This one I got to multiply the top by x plus 3. So I'll distribute the x with the x plus 3. Combine it, it's x squared plus 3x plus 4 over x plus 3 squared. Now you try to factor to see if anything cancels, but you cannot factor x squared plus 3x plus 4. What are the factors of 4 that add up to 3? There are none. 4 and 1 and 2 and 2. Hey, bye-bye.